Hey folks, welcome. We are back this week. Hey, it is, my goodness, it's Tuesday. It seems like a Monday, doesn't it? Because this is Labor Day was Monday and we had a nice, wonderful show about work. Happy Labor Day to you on specialized segments yesterday. But today we're back live. We want you to get those phone calls ready to go. Everybody's back in school again. Oh, it's always a sad thought, isn't it, at times? But we're glad you're back in school. So that way you can give us some answers and questions and all sorts of good things and talk to us here at 844-686-2378. Hope to hear from you this afternoon. I'm Ernie Roberts, and I am your host for the afternoon session of Mathline. Now, what do we do here on Mathline? You give us a call. You call that number. It's toll-free. It doesn't cost a cent. That's 844-686-2378. And have a question ready. Talk to the operator. He will or she will send you to me, and we'll talk about it live on the air and solve it, okay? How about that? Win-win situation. Help you out with your homework, in fact. So give us a call. Once again, that number 844-686-2378. And while you're thinking on those problems, let's check our own problem of the day. Whew, this one's got a lot of words. Hang in there with me, my friends. Taryn has a job. It's a real-life situation here. Has a job that pays a gross salary of $800 a week, plus a 6% commission on her sales. Ooh, on all of them, actually. If she earns a gross salary of $1,640 for the week, what was her amount of sales? Mouthful, isn't it, my friends? Boy, let's see what's going on. Let's talk about this problem. Let's take a look at it and see if we can map out what's going on. First of all, we're talking about gross salary, so we're not worrying about how many deductions they have. These are nice rounded numbers, all right? $800 a week plus 6% commission. You say, Warney, what's 6% commission mean? That means you get, for anything you sell in the store that's credited to your name, you would get 6% of that as an added bonus, so to speak. So we get $800 a week for showing up. Yay, Taryn. But she makes a bonus, okay? She makes a commission, if you will, on her sales of 6%. Now, what we're asking is if she gets $1,640 for the whole week. Now that means her $800 plus this commission amount, whatever it happens to be. We'll figure that out here in just a second. What we want to know is what were her sales? What was the amount of her sales, all right, that she gets credited to her name for doing all that? Wow, that's kind of like a mouthful, isn't it? You know what? This lends me to think of a linear situation, and I'm actually going to go with something like this. I'm going to go with a y equals mx plus b. Slope-intercept form. You say, Ernie, what in the world is that about? Well, it's basically the form of a linear equation. We're going to have a problem that ends up with a certain amount here. We're going to have this slope, which is a rate, and if you will, the rate going on here is that 6%, okay? This x is going to be, how about the number of, or the amount of money we have in sales. In other words, what's our big amount of sales that she's made. And then the b down here, hey, that's what she gets if she just shows up and doesn't sell anything. All right, it's going to be $800 a week. Does that make all sense? All right, so again, so many people ask, will you do some practical problems? Will you show some things where this is useful in the real world? This is a great little example right here, okay? So let's take a look. Let's take a look at this. And you folks at home, go right ahead. If you're watching this out on your computer, go ahead and get you some paper out here and let's fill in the missing details, all right? First of all, y, we'll get to that in just a second. M is the rate, okay? It's like the slope of a line, okay? Because it's a linear equation, all right? It's going to be a linear equation. So let's make that, instead of 6, let's make it 0.06. Over 600ths, because we're going to change it from percent to a decimal. So here we go. Our slope is going to be, see if I can do this right, 600ths. There we go. Make sure that is a 0 there, and there's your decimal. And x is still unknown. That's really what we're looking for. What's the amount of sales? She gets paid what? $800 for showing up. What did she make when all of this was put together? Taryn made $1,640 right there, okay? So here's where we're going to go with this thing. We are going to take, I just might as well fill that all the way in, shouldn't I? Now, what we're going to do here is we're going to subtract 800 and move it over to this side. You say, well, why is that important, Ernie? Well, when we have the 840 over here, and we have this 600th x here, What this tells me, you say, what does it tell me? It tells me actually what her commission is. Her commission is 6% of whatever she sold, okay? And that's $840. Now remember, all my friends out there, and some of you are just tuning in, when we have a situation that looks like this, we have 600 times x. What we need to do to undo this multiplication is divide by 600. So here comes your decimals, my friends. Those of you who love decimals, I see why. All right, let's see what's going to happen. We're going to put it right up here. Let's rewrite it. 840 equaling 600ths of x. And we're going to divide, once again, both sides by 600ths. Now, numbers getting kind of big here. We can do it long ways on paper, but let's save ourselves a little bit of time. Let's go to the calculator and see what it tells us. 840, we're going to divide by, and make sure that decimal hits the right place, a 0 and a 6 there, 600ths, okay? I don't think we need the y equals. Let's clear that out. Let me get the graph out of there, and let me go back to a clear. There we go. All we need is the arithmetic. How about it? Let's take 840, and we're going to divide it by 600ths. Everybody's telling me, that's what you do, Ernie. We know that. So let's see what would happen. We'd have trouble finding y equals 14,000 on our graph, wouldn't we, over there? So that looks like the amount of sales that she has done. So our x value here, our amount of sales, is 14,000. Wow, 14,000. So does it check? Now remember, what did we go back and let's talk about this. This x stood for dollars, and that is the amount of sales. Now a lot of times we like for you to basically, when we got all this stuff going on here, figure out what it is we're looking for. We are looking for this amount x, all right? We already know what the salary is going to be. That's the gross salary of everything she gets for that whole week. We already know how much she makes for showing up. And we know what rate she makes for commission, all right? And we just plug in where it belongs. And now we're going to check. And by the way, it is 1,400 right there. Dollar mark get a little messy there. So let's check it out. If we take 106, or you like to call it 600ths, and we multiply it times 14,000, and we add 800, we hope to come back with what? $1,640. So real quick calculator moment, we'll get this done. Let's see where it goes. We're going to take, this time we're going to multiply instead of dividing with the 600. So let's multiply times 14, get it up there, 14,000. And why not? We'll go ahead and add our 800. And again, we're looking for $1,640 here. Get the 800. See where it ends? Did I say 1,640? I hope I did, because that's what it's supposed to be. $1,640, which is checking back through. So you can check these things pretty easily. Once again, reverse your formula, substitute what you figured out, which was x, and see what happens. So there you have it. Problem of the day. Made you have to think a little bit here. Oh, on Tuesday after Labor Day, I'm a little sluggish too, aren't we all? Speaking of sluggish, let's get those phones ringing, all right? 844-686-2378. We want to hear from you. We want to hear all from East Tennessee, Middle Tennessee, wow, Western North Carolina, Southeast Kentucky, Central Kentucky. Am I leaving out anybody? Oh my goodness, don't forget Western Virginia, right? All of you folks have access to Mathline. Let's make some things happen. Make those phones ring, get our operators busy. Again, 844-686-2378 is that number. So we saw a little algebra today and saw little ways that can help you in a real world situation, wondering maybe how many sales that a girl or a guy have to make in order to get a certain, level of gross salary and gross pay. So that's our start. Let's see what else we can get. So give us some calls, all right, folks? Any age, anyone that wants to turn in, give us a call. We'd love to hear from you. 844-686-2378. In the meantime, while we're waiting for some calls here, let's take a look at another example where sometimes we ask, what good is the algebra going to do for us? Well, sometimes it'll help us get through some easy multiplication that we won't have to go to the calculator. Now you look at these two numbers and it says, multiply the numbers 52 and 48 as a product of two binomials. And there are a lot of ways we can interpret that, all right? A lot of ways we can do this. One thing we can do, and basically what we're about to do is probably exactly how you would do all the multiplications. You eventually add them all together. But let's take a look at it. Let's say if we were to split up 52 as 50 plus 2, and we were also to put this 40 plus 8. Now that's a binomial. It means it has two terms inside the parenthesis. And here we go, another two terms. And we can multiply those together. And we're going to do it. We're going to use what we call the FOIL method. And some of you are going like, oh, wow, I guess we can do that, can't we? Well, it's true. 50 plus 2 gives me what? 52. And 50 plus 8, 40 plus 8, getting a little tongue-tied there, will give us a 48. So let's do the FOIL. Let's look at it as 50 times 40. And I'm just going to put these down here so we'll know where we're going. And FOIL, remember that means the first terms. Now let's go outer. Plus 50 times 8. Let's go inner, because everybody's got to get multiplied by here too. And we'll do plus, what is it, 40 times 2. And on the last, by the way, these were outer. This is inner. And here comes the last. And that's going to be 2 times 6. 2 times 8. I'm ready for 16 to come on the end there. There we go. Let's put it 50 times 40. And we're going to have, looks like 2,000. So we know it's at least 2,000. Let's go to the 50 times 8 out here. We will get 400. Let's go to, how about it? 40 times 2, we'll get 80. And last but not least, we'll add a 16. That's where I was going with that 6 there. Sorry about that, folks. 2 times 8, 16. Piece them all together. Well, it looks pretty straightforward. This is going to give us what, 96? Put a 24, it looks like 2,496 is what we are looking for. 2,496. Again, just add the 2, 400, that's 2,400. Add these two together, you get 96, and you've got the final result. That's one option. I'm going to show you an easier way. There's another connection going on here, all right? If we've got 52, we're going to say 50 plus 2, and we're going to also put on the other end out here 50 minus 2. Now I said, Ernie, what did you just do? I basically made this a sum difference situation. Now, out to the side here, I'm going to put a little something here, an A minus B and an A plus B. And this is one of those things we learn in first year algebra. And we use it again in Algebra 2 and sometimes in our geometry classes also. We love it when we factor both ways here. But what this does, folks, when you do A times A, obviously you get A squared. And look what's going on in the middle. Let's do a little mental math here. AB minus AB, that means whatever those are, AB is positive, negative, whatever, you're going to subtract the same amount, they're going to cancel, all right? So what's going to happen is these are going to cancel and go away. The AB and the minus AB disappear. And let's take a look at, everybody see where I got those? And we've already done the first. We're already going to do the last. And that's all we're really worried with because our middle terms, our outer and inner, cancel each other out. So what I want us to do here is use this same little rule over here. And can we come up with an easier way to get to 2496 if you recognize this is going on? And by the way, this is just the algebra formula type thing of what happens when we talk about sometimes the difference. We get what we call the difference of two squares. And they're perfect squares, what we got there. So let's do it. 50 times 50, 2,500. The last one's minus 4, 2 times 2. We're going to get that one. Everybody see what we did? There's first, there's last. The outer and the inner cancel out because we got 100 and we got a minus 100. So it goes away. And what have we got left here? It looks like the same value, 2496, which is what we got there. And those you really want to know, does it work on the calculator? Well, it should, shouldn't it? Let's just type in 52 and 48 and see what we have. 52 times 48, and we get it, 2496. So different ways we can do some mental work on this. This is really an easy mental calculation, especially since those numbers had those nice patterns going there. It's always nice to have some zeros, isn't it? Because you can always make hundreds out of those when you multiply 40 times a 50 or something of that nature like we did up here even. So either way, that's your answer there for a nice little stretch there, all right? And understand I have a caller waiting for me now, so welcome to Mathline. Who am I talking with? Oh, we have a hang up. That's Sorry about that. Give us a call back, all right? Whoever that was, go ahead and give us a call back. And while we're doing that, how about it? Let's have a Hey Math line. We got one of those going? Did we get there?
Hey Mathline, I'm Alex Schmock from Augusta Prep in Georgia. So if 44,200 fans filled this football stadium to 85% capacity, how many fans could the stadium hold?
Thank you, Alex. Wow. From Austell, Georgia. Great to hear from you. Also at Ripley's Aquarium, where we've done some shooting in the past few summers. Here you go. Wow. 44,200 fans filled a football stadium to 85% capacity. We can certainly think good about those things. We've had a lot of football games already start over Labor Day weekend. And it says, how many fans could the stadium actually hold? All right, so we're saying that we know there were 44,200 fans in the football stadium. It's at 85% capacity. How many fans total could we actually hold if every seat was filled? That was the idea. So let's take a look. I hope we don't have a half a person on this thing. Sometimes we do. But let's take a look at this problem and see what we've got. It's a classic percent problem, be honest with you, but it's also one of these things that, hey, we worry about. It's our college teams, right? If it's our pro football teams, if it's our high school teams, we like to know how many can that stadium hold? Or, hey, we had this many, what percent was filled in? But tonight we know we had this amount and we have the percent. So what I want to do, I want to go back to our friend, the percent formula. And while we're doing that, oh boy, we're running uphill. About that, better. By the way, while we were there, whoever just gave us a call, please give us a call back, all right? We'll try to get you through. We'll give that number, 844-686-2378. And some of you hopefully already at home are already trying to figure out, boy, it's an uphill battle, isn't it? Especially some football teams that happened this weekend. Hint, hint. Now, let's see what's going on. We're going to think about the part. What's the base? In other words, what would be the starting point? The base in this case is what happens if the football stadium is at capacity? In other words, how many seats can it hold? We also will look at that being the percent over 100. So you're saying, Ernie, what are we going to put there? Well, we know the part. We know what the part is, 85%, right? So we're going to put 85 over 100, get that part filled in. That was easy, okay? Because right there, hey, they told us. We didn't have to worry about that. Now, Alex, let's see where we're going to go from here. We are going to pick up, we got to know which one is part of the base. Do we know where we started? In other words, do we know what a full football stadium is going to look like? We do not. We're going to find out, though, how many people should be in there. And the part we have is the 44,200. Big numbers here, so we're going to go to the calculator here in just a second. We're also going to, first of all, let's talk about this thing. It's cross multiplication time. So let us do some cross multiplying. Right, there we go. 85, and again, cross multiplying means basically we work on this diagonal, all right? We don't go across. Cross multiplication means we're making what looks like an X, which is what we call a cross, okay? So they cross each other, and we've got 85 in, and over here we've got, oh my goodness, we're going to put this one in the calculator for sure. 44,200 times that 100. So notice we do need 4 zeros, and we need a 442 also, all right? So not 2 zeros, did I say 2 more? We're going to have to add 2 more. So we got to have 4, count them, 4 zeros total. Woo, that's a big number. So let's hit on the calculator and see where it's going to take us. 44,200, there's 2 zeros, we're going to get 2 more. Why not? Times 100. And some of you said, Ernie, couldn't you just move the decimal 2 places? Absolutely, could move it to the right. Oh, we're going to see an enter? Let's see an enter. How about it? Why not? Whoa, lots of stuff. That's 4 million. That's not how many it's going to have, by the way. We've still got 85 to deal with here, all right? So we've got 85 in, equaling, I told you we were going to add a total of 4 zeros there. We're going to add 2 more to the game plan here. And there we have it. I'm glad it's still in the calculator, so I don't have to re-enter it stuff there. So back to the calculator one more time. Now we're going to divide by 85, all right? So we're going to divide that thing by 85, and we're going to see, where does it go? Gives us a good number there. This is a fairly good sized stadium, probably college, could be pro. They're right around this. So we have 52,000, and that's fans, folks. That's your fans. Now, can we go back and figure out, check it, all right, while we're waiting for a call, or hopefully our caller that called a minute ago to review here and come back together. Let's see what happens. We would want to take and figure out when we put in, if we put in that 52,000, if we go ahead and take it, that 52,000 times 85%, because that's basically what's going on here, right? Change that 85% to a decimal. All right, so we'll take it and multiply it by 0.85 or 85 hundredths. And again, quick job on the calculator here. Let's see what happens when we multiply. We hope we get 44,200. Let's see, put our 52,000 times 0.85. Hold your breath. It is 44,200. So that checks back to what we have in our original problem. Right there it is. And there is your final answer there. So, Alex, there you have it. Great question. And definitely appropriate now that we are in football season in our collegiate, our high school, everywhere. Professional, everybody's playing football right now, right? And you soccer folks say, do you have a soccer problem? Not today, but send us one. Those stadiums are even larger, right? So, again, we appreciate that one from Alex, and we hope you'll give us a call now, folks. It's your turn. 844-686-2378. We want to hear from you. We want to hear from you. And in the same process, let's do a quick little maybe multiplication, algebra, geometry, all sorts of type problem here together. Let's wrap up the show while we're waiting for those calls, all right? We have, find the dimensions of a rectangle whose area is 40 if the length is more than the width. Well, it's certainly going to be more. How much more? 3. All right, so I'm thinking in my mind, how can I multiply to get 40? Because I'm hoping these are going to be nice integral values, integers that are a nice whole number look, okay? So we think of ways that we can get 40. First of all, that's going to be the play with this problem. How about it? Well, 1 and 40 work. But definitely 40 times 1, that is not just 3 more than the width. So that's out. Let's throw that one out. How about 2 and 20? So 2 times 20. I'm going to write these down here just so we don't forget about them. There's 1 times 40. And we said, nope. Difference in those are like 39. So that would be like, that's not going to work. So how about it? 2 and 20. That's another way to get 40. That doesn't sound so good either because that's the difference of 18. I'm working down. How about it? 4 and 10. Whew, there's 6 difference of 6 this time, so we're getting closer. And finally, how about it? 5 times 8. Well, there's an easy way to check, isn't it? That's what we need to get. All right, so if you were seeing this problem on the ACT, boom, 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 so quickly you can go right to your factors, okay? And pick the one that fits that image. Looks great. Now, how about it with those folks who are going to be asked to do this for an algebra factoring test? Yes, let's look at that. So here we go. I'm going to take this and call this width. This is going to be x. This little guy up here is going to be x plus 3. Now, you know, sometimes, and this, by the way, is going to be the length. Okay, so we've basically defined our variables. What's the formula for area? Area is to take what? Area equals length times width. Let's pop them in there, all right? So we're going to, and by the way, you could put w and w plus 3 if you want to do that. That's all right. So in this case, we've got 40 is our area. We knew that. We know that, all right? And how about it? We're going to put in the length, which is x plus 3. And we'll put in parentheses times x. Or we could put the x in front of it. It really doesn't matter. And let's see what's happening. If we'll drop out my lower third for me, guys, we're going to distribute. We're going to distribute backwards. How's that? But we're going to distribute. We're going to get x squared plus your 3x. And remember, when you factor, the whole game plan is set that thing equal to 0. And we're going to subtract 40. We're going to subtract 40 over here. And we're going to end up with 0 equaling, how about it, x squared plus 3x with a minus 40. And you say, Ernie, where's that going to take us? It's going to take us time to factor. Now, we had sort of a factoring thing going on here, but we were making things more compact. Now we want to break this thing open. And it is going to break open. Keep the 0. Don't lose it. That's going to break open into x plus and x minus, and we're going to go with, what did we use, 8 and 5? And if you'll notice something here, how do I know that works? You say, where did that come from, Ernie? I've got 8x minus 5x, which gives me that 3x in the middle. That's what I'm looking for. I've got to have plus and minus because I get a negative 40 to multiply. So again, we break them open, and now we say 0 equals x plus 8, or 0 equals x minus 5. Okay, so quickly over here we've got x equaling negative 8. We know that ain't going to fly. It's got to be a positive length. Over here, x will equal 5. Ha! There we have it. 5. There we have it. 8. 5 times 8, back to 40. And there's the algebra way of getting out of that thing, all right? So, good things. Hey, thank you for tuning in this afternoon, day after Labor Day. And we'll be back again tomorrow. We'll be back again Thursday with some live calls, and we will look for you then.